Hello students. Today's lecture topic is linear variable differential transformer. What is linear variable differential transformer? It is a type of transducer. Transducer means in which one physical quantity is transferred to the another device from one section to another section, and the physical quantity form is also changed into another physical quantities form. Here it is a transducer which converts linear displacement into electrical signals. Okay, so here is the definition. A linear variable differential transformer is an absolute measuring device which converts linear displacement to an electrical signal through mutual induction. This is the main thing. The principle is of mutual induction. Since the name is included transformer. It is a transducer, but its electrical construction is like a transformer. What we know about transformer? In transformer, there are two types of winding, primary winding and secondary winding. When primary winding is supplied with the electrical signal, then definitely according to the primary winding magnitude of electrical signal, the secondary winding is also induced with a electrical signal induced voltage. Okay, that is a transformer. So this measuring instrument having two main components, one is transformer and another is core. As we know that the windings are always wound on a core. Okay, so here is the construction. You can see in the diagram that a transformer consists of three coils. Generally we know that the transformer consists of two coils. One is primary and another is secondary. But here there are three coils. Which are they? In the diagram you can watch that the blue one are indicating the primary winding. This is the cut view of Lvdt, in which it is a hollow cylinder, and above the hollow cylinder the windings are wound. The center blue is the indication of primary winding, and in both corners there are secondary windings. Okay, so the two secondary windings are connected in electrical opposition. I will explain you what is it. Now let us watch that a primary winding and two secondary winding. The primary winding is known as or indicated as P, and the secondary windings are indicated as S1 winding and S2 winding. And the hollow form, which is typically made of glass reinforced polymer. The coils are arranged that the primary coil is located between the two secondary coils. It is the primary coil is at center, which are symmetrical. The two secondary coils are symmetrical and wound in series but in opposite direction. That is known as series opposed windings. Now what is series opposition? That I am showing you in this diagram. Now this is the electrical diagram. In this electrical diagram you can watch that the center rectangular box is the indication of core, and with this core there is a shaft which is of non-magnetic material. It is this shaft or arm is displaced for the measurement of displacement. And since this core is connected with this arm or shaft, so if there is a displacement is in this shaft, then definitely the core will move right side or left side according to this diagram. Now here this is the electrical diagram in which this upper winding is a primary winding which is connected with the source. Here it is shown the AC excitation. AC signal is connected with the primary winding, and the two secondary windings. This is S1. Now at this time it is not connected. These are open. Secondary winding S1, secondary winding S2. If these are open, then if there is a AC signal connected to the primary winding, and then what will happen that since whenever the AC signal is passed through an inductor, then there is a generation of magnetic flux with the same frequency of AC signal, electrical signal, and that magnetic flux, since the windings are wrapped in into the core, so the windings magnetic flux will be connected through this core. And since these two secondary windings are also wound on the same core, so what will be there? There will be electromagnetic induction in these two windings. At this diagram, since the S1 winding and S2 windings are open, so what will happen according to the polarity of this AC signal, within the same polarity there will be the generation of induction of EMF, that is across winding S1 the EMF is ES1, and across S2 winding the EMF is ES2. Okay. Now what is series opposition connection can be watched in this diagram. Here what we are able to watch that what is series connection. If this is a terminal number 1, this is terminal number 2 of secondary 1, and if this is the terminal number 1 and this is terminal number 2 of secondary 2. So what we know, what is the series connection? If the second terminal of one component is connected with the first terminal of another component, that this is a series connection. But this series connection will be known as in series opposition if the second terminal of the first component is connected with the second terminal of the second component when they are already connected in series. Because now see here, if for the first half cycle, if in the right side there is a positive sign and in the left side there is a negative sign, then what will be the electromagnetic induction polarity? In the rightmost side of S2 winding, this is the plus sign. Here this will be the at negative sign. Here this will be at positive sign, and this will be a negative sign. Okay. Now if they are in series connection, so what will happen? First winding negative should be connected with the second winding positive. This is the series connection, when series connection in phase. But when it is connected in series opposition, so as I have told you, the rightmost of secondary 2 is at positive. Okay. And here the right side of secondary 1, it is also positive. So now what we are watching, that both the positive terminals are connected. Okay. So this is series opposition. Series opposition. In the diagram you can watch that here this is a jumper showing. So you can watch that here there is not direct connection. If it is a simple series connection, then these two windings should be connected directly. But here you are watching that via this jumper, it is not connected sign, and this ES1, the second terminal of this winding S1 is connected with the second terminal of winding S2. So this connection is known as series opposition. So what will happen in series connection? We know that the net value of voltage is the sum of both the voltages of two components connected in series. But Here, due to series opposition, the algebraic sum will be actually the difference between the two. So here the output E0 is differential output. That's why it is known as differential transformer, because its output two windings are not connected simple series connection. They are not providing the voltage sum. They are connected in series opposition. It means that the another voltage is actually 180 degree out of with the first one. That's why the algebraic sum will be the difference between the two. Hence it is written E0 is equal to ES1 minus ES2. So with this electrical diagram, you are very much able to understand that what is the differential transformer. Its name is linear variable displacement transducer also it is known, because it is the displacement measuring device. Linear means linear displacement is measured here, and it is also known as linear variable differential transformer. Since it is having in its construction a transformer manufacturing construction, that's why it is known as transformer. And here it is giving the differential output, that's why it is known as differential transformer. So this was the general one, and this is the basic construction of Lvdt. This is the cut view, that this complete is the former, this complete is the former, and here the crossed double crossed lines are showing the windings. At the center the primary winding, and out the two corners windings are secondary winding. Core is inside the hollow former, and this core is displaced either left side or right side with this arm. Okay. Now with this diagram you will be able to watch it the configuration clearly, that if the core is at maximum left, so what will happen? The magnetic flux will be linked more with the S1 winding, and they will connected less with the secondary winding. So at that time the E1 induced voltage E1 will be greater than the induced voltage E2. So the magnitude of output, differential output, will be E1 minus E2. Here in the center diagram, in this diagram, that core is at center. It means that the magnetic flux are linked with the S1 winding and S2 winding in the same manner. So the magnitude of E1 and E2 will be same. Hence it will provide zero voltage, and that is known as null position. And in the right side diagram, the core is maximum right position. So what will happen? The magnetic flux will more linked with the secondary winding S2. So the magnitude of E2 will be greater, and S1 is having the less linkage with the magnetic flux. So E1 magnitude will be lesser. So here the magnitude of E out will be E2 minus E1. Okay. Now if we are making a general equation E1 minus E2, then for the left side movement, left alignment of the core, the magnitude of E out will be positive. The positive value shows that it is moving left side, means direction can be also assigned and checked here with the resultant value of the output. And if in general equation E1 minus E2, if the core is at right side position, at that time since E2 magnitude will be greater, so in the formula E1 minus E2, the output will be negative, and that negative sign will indicate the right side movement. So in this way, Lvdt will be able to show the magnitude of displacement in the form of voltage as well as direction also. So this is the construction of LVDT.